It's time for my speech. Well, good afternoon. Welcome to the clusters API speech. Let me introduce myself. I'm Feng from Google Kubernetes team, and my co-speaker is Zhiguo Hong from Tencent Software Architecture. Well, the agenda of the speech is covering the following aspects. First, what is cluster API and why do we want to develop such open source cluster API and what is the function of that? And then I will take in the upgrading as an example to illustrate cluster API's function. And secondly, in cluster API environment, I want to introduce bootstrapping and the deployment of components of cluster API. And later, Mr. Hong will come to the speech to introduce how to deploy it and give the demo of that. Well, last year, December, in Austin, we launched the Cluster API project and we achieved the rapid development. Let's review the history of that. So why we want to develop the Cluster API. Such a Kubernetes is a standard container orchestration system. So Kubernetes has reached rapid development and it greatly simplifies the operator and the manager's workload. Well, for the creator or manager, it's quite difficult to manage the Kubernetes cluster. I don't know how many of you follow the Kubernetes hardware step by step to create them manually. Please hands up. Well, not a lot of you have tried that. It's a wise choice because it's so hard and difficult. Well, previously, community has produced a lot of tools to address that. For example, we have the COPs, like in the Google Cloud, we have G Cloud, and in Tencent Cloud or AWS or some other cloud platform, we have their respective cluster management and creation tools, and they have different user experience. And in the open source field, we like sharing. So inside the Google, and we have the cluster management tool, like we want to do the scaling. If I want to do the open source, but it's not possible since it will not have much function for the outsiders. So we come up with an idea: can we unify the cluster management and offer the unified interface port so that in various platforms we can have the common standard so that users can access different clusters in different cloud platforms or in public cloud or private cloud, they can have a unified and consistent standard. So if that is possible, when we do the command in AWS or in other system, that will be same. So it will greatly reduce the working cost or difficulties. And for the open source, it is very helpful. For example, the cluster API, if we developed a cluster management or maintenance tool, previously maybe you originally want to develop it for AWS, while later the others find it's quite useful in other cloud platform like the private cloud. You can then promote and apply it into other cloud platform and revert back for the node resources. It's quite a special Kubernetes resource. For the general Kubernetes cloud, we can use a Kubernetes plan to create such resource. But for nodes, it do not have such process. So in these circumstances, we compose that can we use a series of new resources to build the cluster management architecture or structure. So what is the cluster API? What is the definition network? First, it is a series of declarative API. It describes the configuration of the cluster, including the cluster itself, all the machines inside the cluster, machine set, machine deployment are
然
included.
后呢，为了避免大家重复的
But
造
to
功能，
avoid
我
the
们呢这个
repeated
cloud
wheel
它可以不
reinventing,
仅仅是一个 API， 我们还
so the
提供一
cluster
套这
API
个
is
这个
not
共通的实现。
merely an
那
API,
么
but
呢，
it
这个
also
共
offers
通的
a
实现呢，
unified
可以帮大
achievement
家理解
method.
呃 common 的 task 来
It can help others to achieve the common
这个
task,
life cycle 的
like
management，
the
比如
machine
及时的自
lifecycle
动扩展，
management,
这个
cluster
也修
auto-scaling,
复，这些功能都
nodes
可以来
repairing,
这个独立一个个云平台的实现。
and the
然后
achievement
整个
of
架构呢是个
independent cloud
platform， 就是说
platforms, while the
只要
common
这个云平台呢，或者是
architecture
对
is
应的各种云平台呢，
pluggable.
如果能实
If the
现这种
platform
对应接口，
is
那么我们非常
a
容易的把
public
这个
cloud
这个
and it can
功能
offer
扩
the
展到新的平台上。
plugin, then the
所以说呢，
functions are
这是一
easy
个 API，
to
是一个
be
实现，
deployed in other
更多的呢，
platforms.
它是一套这个 tooling
And last but not
里面的
least,
system，
it is
一套
actually
service， 然后大家呢，
a
作为开源的这
tooling,
种，
a
向大家
system
一
of
起把这个
services,
这
and
个
it
电
is
脑
an
变成
open
公司合
source
同。
community. We want everyone to contribute to that.
好，那我来这个更加地步的讲一下到底是什么
Well,
样的
for
API。 它是一个
I would
declarative
like to talk
API，
it
然后呢，来
specifically.
描
So
述
what
这个
is a
机器的配
cluster
置。
API?
然
Actually,
后哪
it's
些
a
配置呢？首先
cluster
一，它是描述这
configuration
个
with
fragmented
declarative
configuration。
API.
这个比如举个例子来说，
First,
比如像这个
it
network，
is cluster level configuration.
那
For
么这里
example,
是
the
一个 cluster
network.
这个 customer resource definition。
This is a
它我
plastic
们在这里面呢，在 step 里面呢，对这
cluster
个 cluster 的
magnification
对
and
应的
management.
网络配置做了一些描述，比如
And I will
所有
just
的
describe the
packet 的
network
range
setup and
啊
the
，port
configuration,
的
like the
这个 domain
range,
啊，
the
所以这
port, the
里我们只
domain.
提供了一个
Please note
描
that
述，
we
就
only
是
offer a
what
description
network，
to
我们给
describe
予
what
这个
it
这个
is,
号，
but not
就对应到我们
offer
对不同的这个云平台，不同的这个
how.
环
That
境
is
呢，
to say,
我们
not
可以
offer the
提供了
method
不
to
同的
achieve
controller，
that.
这些
For
controller 呢，
different
根据自己的
cloud
这个
platform, they
requirement
have
来
different
编成号，
controllers,
比如
while the
说这个在
controllers
这
have
个
different
对应方面，
methods
我
to
们用
achieve
的
that
是
how.
F5 network，
For
那么
example,
我
we
们
use
F5 就
F5 network, then
对
it
对
has
应
a
配置。
F5
那么如果
controllers
在
to
比如
achieve
在
that
这个
configuration.
Google 这个
Well,
Cloud
if you
environment 里面，
run
我
that
们
in
会
the
对
Google
我们
Cloud
Google
Management or
Cloud
Google
这
Cloud
个配置呢，
Environment,
来
then
进
it
行
have
一
a
个
Google
云
Cloud
云平台的这个
VPN
的 controller 来实现。
configuration. It may have
第二
another
种配置呢，
controller
我们讲的是
to
这
achieve
个
that.
machine 的 setup 的配
Well,
置。
for the
比如呢，
second
可以描述这
configuration
个
is about
举个
the
例子里面，你可
machine
以描述
setup.
这个我们需要这个在这个 class 里面
For
主
example,
要
in
3
this
套
kind of
来
class,
3套
we
的
have
machine。
three types,
然后下面呢，这一
three
这一
types
步
of
的这个第
machines.
三个这个
Well, for the
配置呢，
third
就是
level, it's
我
about
讲的平台相关的配置。
a
比
platform
如这里面
related
我们有一个 machine
configuration.
的 resource，
For example, we have the
在这个
machine
machine 的 resource 里
resource.
面呢，
While
这
in
private
that, we
config，
have
对这个
the
config 而言呢，下面有一些
applied config.
这个property 呢，它都是
And
跟这
inside
个
that,
谷歌
the options are connected with the Google
那么假
engine.
设我们现在如果是有一个
And
另
for
外一个
example, we
像
have
Tencent Cloud
another
一个 machine
platform
resource
like the
呢，但是它配置
Tencent cloud platform,
Tencent 的
then the
cloud
configuration might
所以这个我们是
be
一个
consistent
platform
with the
specific
Tencent cloud
最后
platform.
呢，
So it is
我们还要
platform
描述一
specific
下这个云本
configuration.
身的这
But
个
for the
一些
last,
管理，比如
it should
在这个
describe
上
the
面
machine related
对
information,
吧？有个
like the
controller
Kubernetes version, like the
啊，
control plan
这个
version.
master 里面它的
Well, maybe the control plan is only for the
好，
master.
刚才我们讲了，大概描述了一下它 API 到底是描述哪一
Well,
些
for
的这
that was
个
a
cluster 配置。
definition or the
下面呢，
description of cluster
某种程度上
API.
它是一个
Well,
API， 但它也是一
actually,
个
to
通
some
例
certain
，process YAML，
degree,
那么
it is
是
not
process
merely an
CRD 的
API,
这
but
个
also
这
an
个控制
tooling
器。
or YAML or controller
然后但
or even the
看到这个图片，就
CRD.
是从最
Well,
最左
this
边
slide shows
就
that
是
on
这一系列的
left,
从 upgrade 或者是
and
自
we
动扩
have
展，或者是
a series of
repair， 或者
toolings
是
like
加固。
upgrade, like
有必要特意提一下这个
auto-scaling, like
cluster 是
repair.
我们
I
刚
would
刚
mention
设
that
计的
the
这个
clustered
产
control
能力提供这个对这个
or the cluster 2 is officially offered to do the
这
bootstrapping
个基本上是
and
想
the
把
demonstration of
这个
other
标准
functions.
implementation
It
做
wants
出来
to
这个供应方
serve
案。
as a
那这些
as
图片呢，就
a
会这
reference.
个 call into 这个 API server， 然后呢去
Well,
创建这
in
些
that,
我们
once
这个
we
API
plug
的
in that
这些相关的这些
into
resource，
the
包括
cluster,
这
it
些
will
resource
create
cluster
corresponding resources
还
like
有
a
去 set
machine or
deployment。
cluster or machine set or machine resources.
然后呢，有了这个 resource 之后呢，这
With
相关
this
的
kind
controller
of
呢会
resources, the
对
corresponding
这个
controllers
resource 进行 reconfiguration。
will for reconsideration this kind of resources. They have a design state and actual state. The controller will choose which state is suitable. The reconsistent is to say the bootstrapping. For example, when add a machine, what the changes it made to the cluster, or if we delete a machine, what changes it may brought to the whole cluster. If we want to upgrade its node or upgrade the system from previous version to a new version, what changes it might brought to the whole cluster. Well, besides for this kind of controller, actually we have two types. First type of controller is not related to the platform. So no matter whether you want to deploy it in Tencent Cloud or Google Cloud, the controllers are the same. And the other controller is machine controller that is related with platforms, and it visualizes the common features. But if we want to deploy into a specific platform, it needs to be consistent with the specific requirements of each platform.
When these platforms realize the described interfaces, it's quite easy to realize as well. So this machine will be calling into the GCE adapter, and we'll use some GCE APIs to create the VM. So that was about the class API structure, the architecture, what is it for. And next I'm going to explain with an example, why is an API, why is it effective. So about the upgrade, it's very common occasion. Manufacturers or platforms have their own realization for the upgrade of clusters. So let me use one example. If we use class API, all of the realization will be unified. You just need one realization. In this example, if our cluster has 3 nodes, we have machine deployment. There are 3 nodes, and the version is v1.8.3, and we want to upgrade it. We want to upgrade it to 1.9.3. Of course, you can also use a utility to operate it, but it can be as simple as YAML file. You just need to add the YAML file and just to modify it as 1.9.3 and apply for the Kubernetes upgrade. And then under the hood, so in the machine deployment, this is the initial status. There's a machine set. There are 3 nodes, and version number is 1.8.3, so as step 1. So for the machine deployment controller, it will create a new machine set. Of course, there are 0 nodes, but the version is 1.9.3. First of all, it changes the version to 1. So for the machine set controller realizes the replica is 1, so there's a change of status, and then it will be creating a new machine resource, and the machine controller will create such a new node. Of course, afterwards, the new machine set will change the nodes number to 2 and create a new node. So it is a new machine set. And for the old machine set, there's a replica. As you can see, the replica is already 2. The 1 is deleted. And the third step, we change the node number to 3. So we got a new version. And for the old nodes, we only got 1. And we change the replica to 0. And then in this case, we deleted all the old nodes. And for the old machine sets, etc., they can all be deleted. So, of course, this is a simplified process. The time and actual is not really related to the structure or the cloud platform. You can abstract the time. So as long as you realize the adapter, the implementation or the others can be shared. So that was an example of the cluster updating. And next, I'm going to talk about the bootstrapping of the cluster. The bootstrapping is a very interesting topic because there's all nodes in the in the cluster, even master nodes, we want to create that through API. You create a resource, machine resource, and the machine is a master. And in this case, we have a saying that whether you get the chicken or the egg first. So who is created first? You have cluster first, and then you deploy the machine controller to the cluster, or you have the machine controller running somewhere first before you create the master nodes. So that is the question. And so for plan one, for the master nodes, we have some special treatment to it. We have some side channel. To create the master nodes, you can use the API on the platform. And in this case, you will have the old problem. There are a lot of codes can be copied repeatedly, so you're creating the wheel again. And secondly, we're trying to use the Kubernetes to manage the Kubernetes. And this is highly abstracted. For the tool, we have a local cluster. It can be any cluster. It can be Minikube. It can be any local cluster. It can be Docker emmanument. So for the local cluster, you can deploy. You can use the controller as a pod to deploy it, and then as a tool, you can create two resources, including the cluster resource and machine resource. And when the controller has the resource, it will create a real cluster. And in this one, for this resource definitions, etc., you can also copy from one etcd to another one. And afterwards, after you copy all this information of these, you can deploy the cluster API components on the new cluster. And for the old cluster, you can delete that. And the new cluster will be up and running. So here, you can see how the API is there from zero. And next one is the deployment of the cluster. The first one is in cluster or not. So it's a plan one. We call it in cluster plan. In this cluster, we put the machine controller and cluster controller and other controllers. They are deployed as normal pod, so they're deployed inside the cluster. The benefit is the realization is easy and it's easy to understand, but there will be problems with reliability. For example, if a node is broken and I want to replace this node, if it's not master node, if it's a master node is down, I need to replace it. But the pods are running on a master node. When you replace the master node, there's no place for the controller. So it will be not very convenient. You can also use other approaches like HA configuration, etc. But this will make it more complex. There's another deployment called out of cluster. So the manager cluster and child cluster. So for the control panels, they are deployed on the manager cluster, so they are just seen as a normal pod. In this case, if we're going to upgrade the control API and the API or the others, you just need to upgrade the pod as normal, and it doesn't influence the running of the child pod cluster as well. Since the controller is running on the manager cluster, it is also responsible for creating some resource for the child cluster. And for our project, it started from last December. we actually have made tremendous progress for these mainstream cloud platforms like public clouds or private clouds. They actually join the support, providing the support. So we would love this opportunity to introduce it to you, and you can see if you can use it in your own project, and also contribute more to the development of the whole ecosystem. And next, my partner Zhiguo will share with you the application of Cluster API on Tencent.
Hello.
Hello. I'd like to introduce the Cluster APIs support of with the TKE and some operations. And for this one, this is a GitHub page for Cluster API. On this homepage introduction, there are cloud providers realization links. This is the Tencent Cloud. It's a Tencent Cloud's Cluster API provider realization. And the code here is quite simple. So this one says if you want to compile, how you're going to run it, and there is a release here. And in release, there are mainly YAML and examples. So now I'm going to use the YAMLs and examples in release to demonstrate to you how do you create a cluster and add or reduce machines in cluster and delete machines and cluster afterwards. Let's go back to the slides. So for using Cluster API, there are two steps. Step 1, we need a bootstrapping cluster because a Cluster API related controller needs to be running on this cluster. And second step, you can use Cluster API. So now I'm going to demonstrate how to change a regular TPE cluster to a bootstrapping cluster enabled by it. So here I have 3 steps to show you. The first is to install the Cluster API CRD. And you can see there are 4 CRDs installed: cluster machine, machine set, machine deployment. And second one is to install secret. So let me introduce this one to you. So in the release, we have the secret YAML is incomplete. So here, we've got to fill in the secret ID and secret key of your own Tencent Cloud account. So here we got the link for you to get your account ID and key. So here I'm using my own account to fill in the secret ID and key, so I directly create the secret here. So for this secret, it is the TKE's API controller. It needs to use a Tencent API. So in the operation, you will need to use a secret here. And for step 3, for this generic controller and cloud provider specific providers, you need to run them. And they are both operating in the format of deployment. And here I created 3 deployments, and one of them is generic controller. And then we got the machine set controller and machine deployment controller, and the other 2 is the TKE realization.
Well, here are 3 commands. Well, then the bootstrapping before the process is performed. Then the API can do operations on the cluster. But for now, we do not have the cluster. Now we use API to create a cluster. Let's take a look at the definition of cluster. Well, in provider config, we have VPC ID definition, and the definition of domain. And this is in Beijing, and the VPC and the one I created before. And now we create the cluster. Now it is created. Let's check the status of it. Here we can see the status is saying created. That is to say it is in the process of creation. Once it's performed, the status will change it to created. Now back to the management panel, and we find this one, this cluster, is one I logged on. Actually, I logged on one node of this cluster, while the above one, that is in the process, that is loading, is actually the one I defined in YAML. But the controller is using Tencent's API, and it is in creation. But during the process, I will just give a brief introduction. This is to say, creation of bootstrapping is quite easy. Once you have a cluster to run all the controllers, and only if it can access to Tencent's API it will be possible. I have 2 methods. First is to use the official cluster control, and to specify the controller to be Tencent, and then we'll create a local cluster. Well, now I've shown you the second approach, that is to use an existing TKE cluster. And now we can see that the cluster is created, and the version is 1.5.0, and the cluster number is 0. Click in, and we can see the list of nodes is empty. Now I will show you with cluster API, I create the machine deployment. And the provider configure is a related definition of a host running on Tencent Cloud. And we have the IP and the cloud host web configuration, storage configuration, and the size of its resources. And we also have the version of QoS. Now we just create a machine deployment. Once it is created, we found the corresponding machine setting is also created. Now it's different from the common deployment of public set or pod, but it is the same actually. And we can also find the corresponding items are created. And we can check the status of the machine object. Here we can see the Tencent hosted ID and back to the web management panel and reload it. And we can see the list of hosted nodes. Actually, we found these two are loaded. And back to that, we found the machine deployment has 2 replicas. Let me check. Oh, sorry, this is a machine. I made a mistake. Now, previously, have an important parameter that is a replica I forgot to introduce. This is the number of the host, cloud host. That is to say, the number of that is 2. And it's in the creation. The process took a time, it took a while. First, I need to pass through the cloud host and then to do the bootstrapping and to install a series of systems. So it took a while. And here I will show you how to create a TK cluster through the management panel. First, we create a new cluster and specify the parameters, that is to set the version and to choose a domain, to choose network VPC, and to choose the the network section of these containers. And here we can choose whether to use IP tables or IPTVS to achieve the conversion of such kind of services. I forgot to type in the name of this cluster. Well, back to this page, we can find the 2 nodes are created successfully. And here you can show this this is a list. Well, now we make another operation. I want to change the replica. Now we can change the number of replicas from 2 to 3. Back to this page, we found that we have 1 more machine object. Well, back to the management panel. And we found a new node is being created. I guess it will take 1 or 2 minutes. So I'll use this time to introduce other things. Here, I'll show you is a way for users how they can manage the TKE clusters through the API, while for inside of the Tencent cloud. Since we manage over 2,000 clients clusters, so how can we manage that? Actually, we use the cluster API. Well, it's a little bit different. It's slightly different from the community version, different in the format, but the basic process and workflow and content and ideology or idea remain the same. Well, before we're using the cluster API to manage the cluster, we stored the original client information in distributed database. Now with cluster API, we can store this kind of information in API server or ATCB. This way can bring the following advantages. First, it is a declarative API, so it is good for diagnosis and failure recovery, and it has clear code logic. Besides, it can reuse the pattern or achievement or original code from the community practice. Back to, let's check the status of these nodes. Reload it. Here we can see the third node or the host cloud is created. Well, let's do another operation. I will delete this kind of machine deployment and it will automatically delete the host cloud. Now the machine object is deleted, so back to the management panel, reload it. And we found the list in this cluster are all deleted. So I will do the last operation, I will delete the whole cluster. And then this resource is deleted. Well, back to the panel, reload it, and we found the cluster is deleted. So this is my demo. Thank you. We do not have time for Q&A session, but we will stay here. If you have any questions, we're welcome. We can have the offline discussion.